Alright, I'm gonna make this video to talk a little bit about fractions. If you have any questions, feel free to ask me. I haven't taught math for many years now, and I haven't prepared much to organize my thoughts for this. But let's see if I can explain you the basic properties of fraction. Well, fractions are like any other numbers. The only thing special about them is they have this special shape, and they are of the form, what we call it, P by Q, where P is a number and Q is a number, but Q does not equal to 0. That's the only thing special about fraction. Except for that, they behave just like any other numbers. The mathematical property of 1, 2, 3, or any other counting numbers, and the property of a fraction 1 by 2 is not a whole lot different. They behave exactly the same. The only reason we are scared of this fraction is because it looks ugly. To understand anything what we do with fractions, there's one very important thing you have to understand, and everything will fall into places. What it is if I tell you 1 and 10, which one is bigger, or what's the ordering in between them, it's very easy for you. You can say, well, 10 is bigger. That's so ingrained in your brain, right? If I ask you which one is bigger between those two fractions, say 1 by 4 and 2 by 4, here also you can easily tell this fraction 2 by 4 is bigger than 1/4, because a mental calculation what you do is, well, 1/4 means it's 1 part out of 4, 2/4 means it's 2 part out of 4. But what if I had said which one is bigger, 4 by 7 and 5 by 8? The answer is not so obvious. Understanding how you can compare fractions where either of numerators, that is the top ones, or the denominators, the bottom ones, have the same value, is the key of understanding every operation in fractions. So let's do this. How do you compare 4 by 7 and 5 by 8? The trick lies in this. The trick is you have to convert these fractions such that either the top ones or the bottom ones have the same value. What I suggest you do is convert the bottom ones, because that makes your life a whole lot easier for other purposes too. The bottom ones to same value. But how do you do that? Well, the trick is this. You have this 4 by 7. You take the denominator of another fraction, in this case 8, multiply top and bottom by this 8. Again, why did we choose 8? Because we got the 8 from here. Okay. Now, as you know, for a fraction you can multiply top and bottom by the same value. Whereas for this fraction, you multiply top and bottom by 7. Well, why 7? Because the other fraction has the denominator 7. This solves your problem, because now 8 multiplied by 4 is 32, and 7 multiplied by 8 is 56. Whereas in this case, 7 multiplied by 5 is 35 and 8 7s are 56. This thing lies at the heart of understanding everything that happens with fraction. What I mean by that is, if you master this particular process where you convert the denominators of any fraction to a different fraction which has a different denominator, if you understand what's going on here, you can do all sorts of calculation with fractions. Well, first thing, the property that goes into converting 4/7 into 32 divided by 56 is that you have accepted the fact that a fraction can be represented in many different ways. Obviously, you mean 4/7 is same as 32 divided by 56. Fractions are like chameleons. They have many different forms, many different ways to represent the same value. Like you can say 1 divided by 2 is same as 2 divided by 4 is same as 3 divided by 6 or same as 4 divided by 8 and so forth. How do we get there is, the idea is you take any fraction, say 7 divided by 11. You can multiply this fraction, top and bottom, both with the same value, any value, not 0, but any other value. You can multiply this by 5. Then you would have 7 5s are 35 divided by 55. The idea is this fraction is same as this fraction. Doesn't matter what value you multiply with. Say 7 divided by 11 multiplied by 6 divided by 6 equal to 42 divided by 66. We were able to make this conversion of 4 by 7 into 32 divided by 56 and 5 by 8 into 35 divided by 56 because of this property. That is, here we chose 8, in this case we chose 7. Obviously, this choice was very strategic. To convert 4 by 7, we chose 8. To convert 5 by 8, we chose 7. As I said, this was a very strategic choice, and that is at the heart of understanding fractions. First is, what allows us to make this strategic choice is you can multiply any fraction, the top and bottom, by the same value, any value other than 0. In this case we chose 8, in this case we chose 7. Again, why 8? Because we wanted to change this fraction and this fraction such that they have the same denominator. If they have the same denominator, then whatever numerator shows up, we can compare them to get the comparison between these two original fractions. Okay? We could have converted the numerator too. That would have been fine. But for other mathematical purposes, converting denominator is much more convenient. So that's the understanding. You have to compare between any two fractions, convert the fractions such that they have same denominators. In fact, this property can be used to add two fractions. Suppose you need to add 4 by 7 and 5 by 8. Well, you can't just do 5 plus 4, 9, and 8 plus 7, 15. You cannot do this. This is not right. Not true. Okay? First thing you have to do to add 4 by 7 plus 5 by 8, you have to convert these two fractions such that they have same denominators. We know from our previous exercise that 4 by 7 is same as saying 32 divided by 56. And we know from our previous exercise, 5 by 8 is same as saying 35 divided by 56. Now we can add these two fractions. After the denominators are exactly the same, we can just add. 56 doesn't get add up. It's saying 32 parts of 56. Out of 56, I got 32 here. Out of 56, I got 35. You can add the tops and it becomes 67. So the answer is 67 divided by 56. Let's do this in one step. Our goal was to add 4/7 plus 5/8. Now what I do is, I know the strategic choice is to convert them into into 56. I have figured that part out because that is same as 8 multiplied by 7, that is 56. And now, because if you think back step by step, it is equivalent of multiplying 4 by 8 and 7 multiplying by 5. That is 32 plus 35 divided by 56. But at heart, what is really happening is you multiplied this by 8 and 8 plus 5 divided by 8, you are multiplying this by 7 and 7, making this 32 divided by 56 plus 35 divided by 56. Now it's easy pickings from here, becomes 67. Okay? After you have understood this, you can add or subtract any two fractions. Well, the first thing you have to do is convert them into same denominator. How about multiplying two fractions? Well, that is easy. If we had 4 by 7 multiplying 5 by 8, multiplication is easy. Multiplication is what you'd expect. You multiply the tops and you multiply the bottoms. 4 multiplied by 5 is 20. 8 multiplied by 7 is 56. Multiplication is easy. What if you had to do 4 divided by 7 divided by 5 divided by 8? Another way to write this is 4 divided by 7 divided by 5 by 8. Only thing to remember is the top fraction remains the way it is and you flip the bottom fraction. So 32 divided by 35. Okay, so we learned three things: how to add two fractions. If you want to add 4 by 7 and 5 by 8, or any two fractions for that matter, you have to convert them into same denominator. We did that by strategically choosing the other fractions denominator. 5 by 8 plus multiplied by 7 by 7, that is same as saying 32 divided by 56 plus 35 divided by 56, and then we just added the tops, 67 divided by 56. This was our first thing. The second thing, we had to multiply two fractions. That is, as you'd expect, the top multiplied by top, the bottom multiplied by bottom. We want to divide one fraction by another fraction. We keep the top fraction the way it is and we flip the bottom fraction, that is 32 divided by 56. That's all there is to all the fraction operations. Now, what if one of the value is not a fraction? Well, what if it was 2 plus 5 by 8? Well, the only thing you have to remember, 2 is fractionally same as saying 2 divided by 1. Well, after that, it's easy. We want to convert this again into same fractions. The strategic value, so that we can multiply the first fraction, is 8, 2 multiplied by 8, plus for this the strategic value is 1, 5 divided by 8 multiplied by 1. So we have 16 divided by 8 plus 5 divided by 8 plus we got 8 and 8, that is 8. 16 plus 5 is 21. What if we had to divide? 2 minus subtract 5 by 8. Well, the same thing. We have to understand that 2 is same as 2 by 1. Then again, the strategic number to multiply this 2 by 1 is the denominator of the other fraction. Now that is 16 divided by 8. We have minus. Here the strategic choice is 1 divided by 1 because there is a denominator of 1. So we have 16 divided by 8 minus 5 divided by 8, which is same as saying 16 minus 5. The bottom stays 8. 16 minus 5 is 11. So our answer is 11 by 8. That's all there is when dealing with multiplication, division, addition, and subtraction of fraction. The trick is in converting the bottoms, making the bottoms same. How do you make the bottom same? Is choose a strategic number to multiply each fraction with. One easy strategic choice is the denominator of the other numbers, and this always works, because if you had a fraction 5 divided by 6 and you had another fraction 4 divided by 8, the strategic choice of 8 here, because the denominator is 8 here, the strategic choice of 6 here, because the denominator is 6 here, always yields you the same value on the bottom, is because 8 times 6 is same as 6 times 8. We don't care what value we get on the top. 8 multiplied by 5 is 40, 6 multiplied by 4 is 24. The only thing we are saying is 40 divided by 48 is same as 5 divided by 6. 24 divided by 48 is same as 4 divided by 8. Now you can do subtraction and addition between these two fractions by working on these two altered fractions. The only beauty of this is they have the same denominator, allowing you to concentrate on the top. Alright, hope you understood something. Thank you.